Alright, let's implement some sorting algorithms in JavaScript. So the array in question that we're going to sort is an array with 1000 randomized integers, and we can make this array by just making a for loop and appending random numbers using mass.random and multiplying it by 1000 and using mass.for so that it is whole numbers. Note that this array can contain multiple elements with the same number and also have numbers that don't exist at all, but that's perfectly fine for this situation. So there are a few words and jargon that you need to know. Big O notation is, according to Wikipedia, a mathematical notation that describes the limiting behavior of a function when the argument tends towards a particular value or infinity. This can be used to calculate time complexity, which is a way of measuring how long it takes for a sorting algorithm to run. For example, O1 time means that it is constant, which means that the time for sorting doesn't change depending on how much stuff is in the array. On time is linear, so for example, 10 elements take 1 second to sort, 20 elements take 2 seconds to sort, and 100 elements take 10 seconds to sort. On squared time is polynomial, so for example, 10 elements take 1 second, 20 elements take 4 seconds, and 30 elements take 9 seconds. There are a few other time complexities, such as exponential time, logarithmic time, and factorial time. Okay, so the first algorithm we're going to look at is QuickSort, and it has a time complexity of n squared. So this is how it's going to work. We have to first choose a pivot, which is a random element. So let's just choose this one as a pivot. And what we can do now is that we find everything that is bigger than the number 4 and move it to the one side, like this. And we put everything that's smaller than 4 on the other side. So 3 is smaller than 4, so we just move this thing here. 0 is smaller than 4, so we move it this side. Let me just move everything back a bit. And 2 is also smaller than 4, so we move it to this side. And now you can see that although it is obviously not completely sorted, one side is smaller than the other. So what we can do now is recursively do this again. So choose another pivot from each side. So let's say we choose, I don't know, 2 as a pivot here. And we can choose any one of these, like 6 as a pivot here. So what we do now is move everything that's smaller than 2 to this side, like that. So we move like this. And now we also do this, everything that's smaller than 2 on this side. So now what we can see is that because there are only one of these left, we can be sure that this part is already sorted. Now we just need to do this again. From this side, we can choose another pivot. Let's change the color of the pen again. Choose a pivot. Let's just choose 1. Now we move everything that's smaller than 1 to the other side, like that. And now we can technically still choose a pivot for 3, and then move everything, but 3 is already one of them, and 5 is already only 1. So basically we can be sure that it is done now, and we can just return the array, and this sort will be complete. Okay, so to write the function, let's just say function QuickSort array. We pass in the array, so we can first check if array.length is less than or equal to 0. If yes, we can just return the array itself, which is an empty array because it obviously doesn't need to be sorted. Now, what we do is we create a let pivot, so we choose a pivot, and we can just set it to the zeros one. We don't need to pick a random one because the numbers aren't in order anyways. And we can just create 2 arrays called array left equals this, and the array right equals an empty array. Ideally, you will sort it in place without creating new arrays because that wastes a bit of memory, but this helps illustrate it to you a bit better. So we can just loop through all this. So for let I equals 0, I less than r.length, I plus plus. So if array I is less than pivot, then array left, we just add that to the left array. So dot push ri, and then we can just copy and paste it again and then do this. notice how I'm not using else because we want to exclude the pivot from both of these arrays. We don't want to add that to it. So because we use less than greater than, if it's equal, it doesn't work. So now we can just return it. So what do? We quicksort the sub arrays. So the left array, we quicksort that also. And then we concatenate it, add the pivot to it, and then we also concat the other array. So quicksort array right. So now what happens is that if we do console.log quicksort array, you can see that it should work nicely. See, 0, 2, 3, 4, 5, 6, 7. As I said, like there's skip some values, but this is basically how it works. That's not a 1, that's a 14, 15, 16, 17, 18, 19, 20. So we have done this. And what we can also do is console.time. Console.timeEnd. And then we can just see how long it takes. 14 milliseconds. Okay. Also, it's worth noting that when you time it, the console.log takes a lot of time. So if you just remove it and use the time, you can see that it takes much shorter amount of time. So that's a lot better. Okay, next we're gonna do bubble sort, and bubble sort is very simple. So what it does is repeatedly goes through an array, and if it just compares two elements. So if one of them is the first one is bigger, it just swaps them, like that. Now what we do here is that it compares 4 and 5, and you can see that 5 is still bigger, so it swaps these. And now it compares 3 and 5. 5 is still bigger, so it swaps these, and you get the point. 5, 0 is swaps like that. And then 5 and 2. I'm just gonna speed this up now, and you can watch it time lapse. And now it stops. So what you can see it's doing is basically it keeps shifting the final number until it reaches one that is not as big as it. So basically it keeps shifting all of the big numbers to the bottom, and eventually it's sorted. To write the bubble sort function, we do this. Let's just delete the console.log one before. Bubble sort. And this can take in an array. And because we'll be changing the array, let's just make a copy. Let array. Maybe we can just make this array, and r equals, and we can use the spread syntax. And you can see how the bubble sort repeats in a lot of times cycling through the list until it's sorted. So what we can do is actually, this is one of the rare times that you can use a do while loop. So let sorted equals false. And every loop we can also do make it sorted equals false. So how do we do this? We do it while sorted is false, so while not sorted. And then we can just return array or r. Now we just loop through every single index. Let I equals 0. I less than r dot length I plus plus. Actually, we can start at 1 because it will I think it would be better to compare the 1 and the one before it. So if I less, I is less than, or r, like the previous one is greater than this one, the current one, then we swap these. So a nice way we can swap it is using object destructuring. So basically we're doing I minus 1, and we can just make it equal to another array of like this, like that. So if this seems confusing to you, it's basically you can see that there's both two arrays with 2 elements in it. It basically knows to swap the values, so we don't need to use a temporary variable. Yeah, so what we can do here is that actually we can let sorted equals true here, and if they're ever looped, we can put it here. So sorted equals true, false. So basically it means that every time you move something, that means it's not sorted, because you did something to sort, that means it's not sorted yet. if we run this, you can see that yeah, I forgot to do this. So console.log bubble sort array, and you can see it's 0 0 1 1 2 3 3 5 6 8 10 10 13 14 15 16 20 20 21 20. So you can see this works really well. Okay, so insertion sort is pretty similar to bubble sort, except this time when we see that this one is smaller than the previous one, we don't just like swap them and continue going. We continue to check if it is also smaller than the previous one. So for example, 1, we can check if it's smaller than 5. Yes, it is. We swap these. But we also check if it's smaller than 0, which is not in this case. And also here is the same thing. We check if 4 is smaller than 5, which it is. But 4 is not smaller than 1, so it stops here. Now this is a part where it says it continues going. So 2 is smaller than 5. Yes, it is. We swap these. Is it also smaller than 4? Yes, it is. So we swapped it again. Now we look at 6. Is it smaller than 5? No, so it just stays here. Now we look at 3. Is it smaller than 6? Yes, it is. We swap it. Is it smaller than 5? Yes, it is. We swap it. Is it smaller than 4? Yes, it is. We swap it. Is it smaller than 2? Nope. So we just move it here, and now we have a sorted array. So let's write function insertion sort array, and we're going to do the same thing as bubble sort, where we copy the array. So let r equals dot array a, and then we just loop. All we need to do is loop through this like a normal for loop. I equals 0, I less than r dot length, I plus plus. So what we do here is also we do one because we're comparing with the one before. So while array I minus I is less than r I plus I minus 1, if it's less than the one before, what we do is we swap these. So kind of we can just actually literally just copy and paste this exact thing. But what we do here is that we don't stop, we keep swapping these. So, and also we can use a j to keep track of this position. So let's say let j equals I. So while j is less than j minus 1, and so we can just change all of these for j. And after we swap this, obviously this element becomes the one previous, so we can do j minus minus to decrease j by 1 to keep track of the position. So after we're done with everything, we can also just return the array. And let's see if this works. Console.log insertion sort r, let's see. And you can see it does. 0 0 1 1 4 8 9 11 13 13 14 14 15 15, yeah, etc. Okay, so I'm gonna explain merge sort a bit differently than what I did with the other one. So I'm just gonna draw it. So first of all, what we need to do is that we split it basically into a bunch of pieces. So first of all, what we can do is split it in half. So this side becomes 5 0 1 4, and this side is 2 6 3. And now we split it in half again. So this side becomes, of course, 5 0 and 1 and 4. These are separated, by the way. And this side is also the same, so we can have 2 6, and then we can just have 3. And now we just split it again, so we can have 5 0 1 and 4, each on its own separate array basically. And 2 and 6, and the 3 will just go here and become a 3. Now let me just shift everything up a bit. Okay, so now what we do is basically we sort each of these individual ones, because we now have a guarantee that each of the individual subarrays are sorted. So we can just sort this, so we can put 0 and 5 like this using some way. We can just compare them. And here we can just sort the first, whichever is larger. So which one is smaller, so 4 yeah, we can just merge it back, so which is where the name comes from, to a smaller array, so 1, 4. And here's the same thing, it's already sorted here, so 2, 6, that's an array. I can just put array symbols brackets here if that makes it easier to understand. Same with here, like that. Yeah, something like that. I'm not gonna do all of them, but okay, 3 still just becomes 3 here with an array like that. And then we can sort, merge these two arrays. That seems like a bit complicated, like you were just sorting it again, but actually this is easy because every time we can just add the 1 from the beginning thing. So first of all, we can say 0. Okay, 0 or 1, which one is smaller? 0. Okay, now we go on here, 5 or 1, which is smaller? 1. So we do this. Okay, now we have both of them, so we do 5 or 4. 4 is smaller, and now this one is gone, so we can just do 5. So now we have this list that's sorted, and then we can do the same thing, 2 or 3. 2. Okay, 6 or 3. Obviously 3, and then we have 6 left. So now we have 2 of these things. And now we can also just sort it back in the same way, so 0 or 2. 0. 1 or 2. 1. 4 or 2. 2. Okay, so 4 or 3. Still 3. Now 4 or 6. We can put 4 here, and then we can, we can cross these out if we want each on the way, and then we can say 5 or 6. We can say okay, 5. So we cross out 5, and now all of these are crossed out on this side, and 2 and 3 are crossed out, and now we just put 6 here, and now we have the correct sorted array. Okay, so merge sort is also going to be a recursive function, so let's just do merge sort array. Let's copy the array, so let r equals ... array. And now what we need to do is find the midpoint of it. So what, like let mid, let us say mid equals array dot length, or r dot length divided by 2. But now this can be decimal points, so we do floor, mass.floor. And now we have the midpoint. We can just separate it into 2. So we can say let, I don't know what we should call it, part array, I guess, equals our array dot splice. We splice it from 0 and splice it all the way to the midpoint. So we don't actually need another part because splice actually modifies this array while returning the part it was spliced out. So let's see if this does what I think it does. So console.log array, console.log part array. So now we just do console.log merge sort r, and yeah, you can 400 more items, and prints out 100 on. But basically there's that many items, and it's split it in 2. Great. It's not sorted at all yet. So what we can do is that actually before we can say if array.length is less than or equals to 1, we can just return the array itself. And let, and then we can say merge sort part array equals merge sort array, and then part, and the array equals merge sort array. Okay, so now we have the 2 parts, we can actually merge it together now. So remember, like this part, this variable and this variable are both 2 parts of the array. So with this, what we can do here is merge. So let's say let whole array equals this. So we do while at least one of them is not empty, so while r dot length is not equal to 0, or when part array dot length is not equal to 0. So if array 0 is less than part array 0, so that part, we can just put our whole array dot push r0, and then we can just say r dot shift. Shift is basically like a fancy way of removing the first element. Because we already pushed it on 0, we can just delete it. And whole array dot else, if it's not less, we can just say part array. So this is basically what I said here about the diagram of like comparing the first two, and then push the add the smaller two on here, and then like slash it out, and then we just continue doing that until both of them are gone. So we do that, and then do part r dot shift, and then we do return whole array. If I did everything correctly, I think that's all there is to it. Nope. Yeah, I did something wrong. Okay, so I just messed up a few small things. We want to change the part array to be like the sorted part. So of course we're not passing in the original array, we pass in itself basically. And now for the whole array, I just realized that if one of them is like empty, then it will be undefined. It will try to continuously push undefined ones into the other ones. So a good way we can do this is basically using AND. So to ampersand, so like if either of them is empty, it just like breaks. But what about the part that's left? Like if one of them is longer, what happens? We can just concatenate the rest here. So concat array and then dot concat, because if one of them is left, we don't need to compare anymore because the other one is already empty. So obviously those will be all bigger than the other ones, and this would be the sorted array. And you can see if we run this now, it will be 0 0 1 1 2 2 2 2 3 4, and then it's all in order. If you still don't understand quite how this works, I'll try to explain it once again. Basically what happens is that we split it in two, and then we sort each of the parts individually. And then after we have two separate sorted arrays, we put the two sorted arrays together into the entire sorted array. So we make a whole array, and then we add whatever from the beginning, because both arrays are already sorted, so we can be sure that the first one of either array is definitely the smallest one of that array. So we just get the first index and compare whichever one is smaller, and then just push that onto the whole array. And then we just continue pushing each of these arrays until we fill up the whole array and both of them are empty. And I changed it a bit so it breaks the loop whenever one of them is empty. So we just concatenate the remainder, so like the rest of the ones, in case both of they are two different sizes or something. So we just concatenate the remainder ones, and then they will be completely sorted. And you can see that recursion might be a bit confusing to you, but this you can just think of it as a way of sorting, because it's a sorting algorithm. You just sort the parts, but basically it sorts it the same way as you sort the whole part, and it just continues you calling itself until the length gets divided into just one, where it just returns itself, and then it can continue. I hope that explained it clearly. If not, I guess you can try to go back and look at this explanation of my diagrams and stuff. Okay, so the final sorting algorithm that we're going to look at is counting sort. And what counting sort does is essentially counts the amount of elements that are in an array, and then stores the count of it into the index of the value. It will be easier to understand if I just demonstrate it. And this algorithm only works really well if you know the amount of different values. So for example, numbers, we can know that the lower bound is 0, the upper bound is 4. So there must be 5 different unique values that can possibly exist. So what we do now is we create an array of the amount of different elements, and then what we do is just do this, and we just number this from 0 1 2 3 4. So we go, and then the first one is 2. So we add 1 to 2 because there's 1, 2. Then the next element is 0, so we add a 1 here. And then there's 1, so we record a 1 here. And then there's 1, 4, so we record a 1 here. Now we see another 2, so what we do is we erase the 1, or we just increment here. And then because there's 2 2's now, we put a 2 here. And now we can see that there's another 1 also. So what we do is we go to the eraser, we also increase this by another 1, so there's like this. And then at the end, finally, we see 1 of the 3. So what this means is that we have recorded the amount of things, the amount of elements that exist with the same value. So what we can do is just go from the beginning. There's 1 0, we write a 0 here. There's 2 1s, so we can just write 1 1. And then there's 2 of the 2, so we write 2 2. There's 1 3, so we write a 3. There's 1 4, so we write a 4. And now the array is sorted. Okay, so let's just write function counting sort. Pass in the array. And now let's just create a new array, count array. So this would be an array of length 1000, because we know that the numbers we are starting with is randomly ordered from 0 to 1000. So we have a length of 1000, and then we fill it with zeros because there's none elements for each value yet. And now we can just loop through the numbers for number of array for let number of array, and we can say count array number, so at that index we plus plus. So if there's a number there, it adds 1 to the corresponding index. So if we console.log the count array here, you can see what I mean. So counting sort array, and you can see there's 0 1 0 2, and this is basically the amount of elements with that certain value. So there's no zeros, there's 1 1, there's no 2, there's 2 3, there's 1 4, there's no 5, there's no 6, no 7, no 8, but there's 1 9, there's a 10, there's a 11. You get what I mean. And now if we want to make it into like the actual sorted array, all we have to do is create a new array, let final r equals nothing, and just loop through all of the indexes. So for let I equals 0, I less than count r dot length, which is 1000, and then I plus plus. So we push the number of elements there. So if there's no 0, we don't push anything. Because there's 1, we push 2 1 there, and then because there's no 2s, we don't push anything. There's 2 3s, so we push 2 3s there. So a nice way we can do this is final r dot push, and so we can say array of that count. So count r I, which stores the number of elements with that value, and then dot fill, we fill it with the index, which is I. Now you can't just do it like this, because if you push, it thinks it's an element. So what you need to do is dot 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 using spread syntax. So now it's kind of like concatenating, but also mutating the original array. Now we can just return final array like that. So if we just console.log this, you can see 0 1 2 3 4 5 12 13 14 15 16 17, and it's all ordered nicely and correctly. So today we learned 5 different algorithms. I hope you learned something. If you did, please like and subscribe, and see you next time.